Hi, so yeah, I've never made a YouTube video before. I might well never make one again. But I'm not going out at the moment. Not much to do today. Obviously, a lot of crazy stuff going on in the world at the moment. So what I'm going to do here is I'm just doing a little video tutorial to guide you through the process of writing and building a custom PHP extension written in C on Windows, and we're going to see that process on Linux as well. It's a bit harder to do on Windows, and I found that as a process um, it's more poorly documented. It's harder to find the information on how to do it, and it can be a bit of an obscure, arcane subject. So I figured this was quite a good thing to do on a Sunday afternoon. So I'm going to walk you through that process, and we're going to make a very small PHP extension, and we're only going to add sort of one new custom function to PHP. But it's I'm going to explain the use case, and it's hopefully going to be a useful thing to do. And we'll go through all the things we need to know to do that. So you can see I've got open here in my browser, I've got on the Microsoft GitHub section, I've got open the PHP SDK binary tools. Now this is something we're going to see more about in a minute, which is the SDK for building on Windows. Just to quickly talk about the prerequisites for following this through. You're going to want Git installed on your machine, because obviously we're going to be cloning things from GitHub, and you're also going to want Visual Studio with desktop C++ support enabled. Which version you need kind of depends on which version of PHP you're building. If you're building for 7.2, 7.3, 7.4, you're going to want Visual Studio 2017. If you're building sort of latest bleeding edge, if you're building off PHP Source Master version 8 dev, you're going to want Visual Studio 2019. You can actually install both those side by side. Probably see on my machine, yeah, 2019, and I got 2017 running on there as well. There we go. So yeah, do install that with desktop C++ development option enabled, and you'll be good to go. Those are the only two prerequisites you need, other than what we're going to follow through here. So yeah, first thing I'm going to do, I've just created an empty directory on my hard drive, fsync PHP extension. Fsync is the name of the function we're going to add to PHP, and I'll talk more about that later. So I'm just going to clone this repo down into a directory called PHP SDK. Quite a small repo, this one. It won't take long to get it pulled down. What it contains are a bunch of batch files and a few binary tools that are similar to what you would see on some Linux systems, which have been ported over to Windows, which are necessary for building PHP. So you see we've got a few batch files and utilities in there, and indeed in the PHP SDK folder. What we're going to look at here is these batch files, which correspond to versions of Visual Studio, and what they do is they set up a command prompt environment for you with all the right tools in the path, so that you don't have to faff about. You can just run some fairly simple commands and get things going. One thing I would say is these things you're seeing here can be a little bit confusing. VC15 actually refers to Visual Studio 2017. It refers to the Visual C++ compiler that is bundled with that. VS16 is what you'd run if you were running Visual Studio 2019. So yeah, it can potentially be a little bit confusing. And you can see we've also got versions of each one for target architecture, 64 and 32-bit. Now, on my machine, I mean, I do have several different versions of PHP on this machine, but the one that's just default in my path is the PHP from my local XAMPP installation, which, as we can see there, is PHP 7.4.2. And this is a thread-safe version built with Visual C++ 2017, and it's 64-bit. Thread safety, of course, is typical when it's built as an Apache module, which obviously it is when you're running it through XAMPP. I'm not going to sort of talk about that in detail now. It's something you can read about, but suffice to say there are thread safe and non-thread safe versions of PHP. And when you're building an extension, one of the most important things to consider at first is that you do have to build for the right PHP version, the right platform, the right thread safe or non-thread safe option, and the right target architecture. So if I want to compile an extension, as I'm going to do now, to run against this particular PHP binary that I've got here, I've got to make sure that I have those settings correct. Otherwise, I'm going to build an extension which on Windows is going to come out as a dynamic link library, a DLL file, and if I try and plug that into a PHP version or architecture that it was not built for, obviously it's not going to work. So the first thing I'm going to do is I'm going to set up my command prompt environment, and we can see from the information we've got here that the target that I want is Visual Studio 2017 64-bit. So that is that PHP SDK VC15x64 batch file, and we'll just go ahead and run that. And as long as you've installed Visual Studio correctly, this should just run fine. You shouldn't encounter any problems doing this. And you can see it's just set up a command prompt environment for me where I've now got the binary tools in my command prompt path, and everything should work nicely. So before we carry on, we're also going to need something else. If I jump back to the browser here, windows.php.net/download/releases. This is, of course, where you can download Windows builds of PHP, but more importantly, we can also download, as you see on the screen here, we've got the PHP developer packs. And what that includes is another batch file and some C headers and libraries that are going to be used to build PHP extensions. So again, it's very important to get the one that matches the right Visual Studio version and platform and version of PHP and target architecture. If I go into the archives folder here, where we find all the older PHP releases, and I scroll way down, see I found 7.4.2, which is my target PHP build. And I am using the thread safety NTS there is non-thread safe, so I want the one that is for thread safety. And that is, again, that is Win32 VC15x64. So I'm just downloading that into my little project directory, and I'm just going to extract that here with my totally paid for and licensed copy of WinRAR, and I'm just going to rename that folder PHP dev. Now, of course, there is one more thing we're going to need to do this, which is the actual PHP source code. So that's also available on GitHub. And I'm just going to grab the reference to that there. Now, before I go ahead and clone that down, what I'm going to do is I'm going to run one of the scripts that are included with this Microsoft PHP SDK for Windows pack, and that one is the one you can see, PHP SDK build tree. And again, because I've run that batch file, set up my environment, I don't actually need to be in the binaries directory for this. This command will be available. So what's that actually done? Well, if we have a look in the file explorer here, you can see it's created a folder called php-7.4.2 VC15x64, and it's created this deps folder. Now, these bin include lib, these are actually empty at the moment. There's nothing in there, it's just created these directories and moved me into VC15x64 on the command prompt. Why are we doing this? Because in the real world, if you are writing and compiling a PHP extension, in all likelihood, you're going to want to compile it against numerous different platforms, architectures, and versions of PHP. And what we're doing here is we're basically just making sure that our dependencies don't get messed up and they don't get mixed up with each other. So now that I'm in here, what I'm going to do is I'm going to pull down from Git the PHP source. Now, as you can imagine, the PHP source is quite large, so this is going to take a little bit of time. Obviously, if you're watching this on YouTube, you have the luxury I don't of just being able to skip forward a few seconds. But I've done this before on my machine, so it probably won't take as long as it would on a system that you've never set this up on before, because it's probably going to be able to load a few things from cache. Once we've gone through all this, by the way, we're just going to build the same extension on a Linux virtual machine as well. Just see, you can write extensions that are cross-platform and will easily compile to um, different platforms, different versions of PHP. Feel free to skip forward probably about 15-20 seconds while this does its thing. Okay, so we've got the PHP source code checked out. Now what I'm going to do is I'm just going to go into that directory. We don't really need to have much of a look at this stuff at the moment, but you can see I'm currently on branch master. That's not the branch I want because that's currently at the time of making this, that's PHP 8.0 dev. That's not even going to compile against the Visual Studio 2017 environment that I've set up here. So I'm going to check out the particular branch that I want, which is PHP 7.4.2. And again, we'll just wait a moment while this switches over to the right set of files. Okay, so now I'm on the correct branch that I want for the version of PHP I'm building against. The next thing we're going to do is we're going to download some other dependencies, but we're going to do this through a little command line tool, PHP SDK deps. Now, what it's actually doing is it's just running a little script which you can see it's downloading some of the things that some of the libraries that you require to build a working PHP distribution, and you can see it's got the VC15x64. So that's what this script does. It just resolves the correct dependencies for you and downloads them over the internet. And again, it'll probably take a couple of minutes to do this. But I think following this video, you're going to be surprised. If you've got the prerequisites installed, I think you're going to be pleasantly surprised at sort of overall how quick and painless it is to get a shared extension built. Well, we're looking at this libffi. I expect that would be referring to the foreign function interface in PHP. I've never actually had a use case for that myself in the real world yet. If you have, I'd be interested to hear about it. Yeah, obviously you should recognize a lot of these libraries it's downloading. And you can see a lot of dependencies are now appearing in that directory structure that was created for us. So the next thing we're going to do is we're going to run this command buildconf, and that's just going to generate a configuration script. And as you can see, it's now going to tell us to run configure --help. So yeah, a lot of the switches that you can run this configure with, they control essentially self-explanatory, they control the configuration against which PHP will be built. And you probably recognize some of these options. If you ever looked around in say, the PHP manual, um, for curl, for example, if you go to that documentation and you go to installation, you'll see it will say to install this extension, PHP should be built with the dash dash with curl option. Um, and it's actually this configure script to which that kind of thing refers. So we could go ahead actually and do a build of a PHP binary and produce a php.exe on Windows of PHP 7.4.2. I'm not going to do that now because I want it to be as short a video as possible. We're interested in building an extension. You don't want to sit around for 30 minutes while PHP compiles on my laptop. So what we're actually going to do is we're going to jump straight into the interesting part. If I just show you the contents of the ext directory in the PHP source, and now, of course, if you install PHP on your machine, you'll know that ext is where all the extensions live. And of course, we've got all the ones we're familiar with here in the PHP source. We've also got this little script extscale.php, and that's a neat little script which will generate a skeleton PHP extension for us that we can compile and see running, and it'll be like a sort of basic hello world extension, but we're going to quickly do that just so we can see the process of building an extension and installing it. Now, if you just run this as it is, it's going to say that it expects a command line parameter, but it only expects the one, which is the name of the extension. So there, I'm going to create my extension, fsync. We'll see more about what that is in a moment. As you see, it just says, it's just copying some files, and all it's actually done is it's just created a new, in the extensions directory, it's just created a new directory called fsync. So if I hop into that, and indeed, I'll show you in Windows Explorer as well. What it has done is just put in some configuration files, an fsync.c and a phpfsync.h file, and it's these two files that we're going to be interested in looking at more closely in a moment. And there's also a test folder, but I'm not going to go into into tests in this video because, again, I want to keep it as short as possible. Now, essentially, to build this, obviously I downloaded that PHP developer pack, and that's got phpis.bat in it. Now you probably, if you've just if you've got a development environment set up, you may well just have phpis in your path. I have several different versions of all these things installed on my machine, so I'm explicitly referencing the full path here. But within my newly created extension directory, I'm just going to run that batch script. And you can see that what that's done is that it's created a configuration script and a configure.js file. And what it's doing really is it's just generating the configuration for the specific version of PHP I'm compiling against. It's just saying where this can find all its various dependencies and headers and libraries. And now if we run this configure -- help again, we will see at the bottom there is a -- enable fsync support, and obviously that's my new extension. So I'm going to say that I want to build this with fsync support enabled, and what this has done is just running that has, again, you can see it's altered the files in here. It's created a make file for Visual Studio, and it's just confirmed that I have all the dependencies that I need to go ahead and build this. So now I just need to type in nmake. And the Visual C++ compiler has gone ahead and built that for me. And now you can see in my extension directory, I've got this new x64 folder. Inside here, we're going to find a folder called release.ts, because again, I'm building the thread-safe version. And in here, we have phpfsync.dll, which is our actual extension file. Now, of course, we haven't done anything with that extension. We haven't even looked at the code. We're going to do that in a minute. But I mean, in terms of the process of building an extension, that's it. We've actually done that. And if I open up, there's no particular reason I'm using git bash here, by the way, other than it's just, it's just convenient. Um, so if I navigate to this, where am I at? PHP SDK, PHP 7.4.2, VC15 x64, PHP source, ext, fsync, x64, release ts. Okay, and again, just to remind you, I'm using my XAMPP PHP 7.4.2, and so this is the version we've compiled against and that we're going to put this extension into. So what I'm going to do is I'm going to copy that dynamic link library to my XAMPP installations extension folder. So one last thing we're going to do here is we're going to enable this extension. And now if there's any problems, we're going to know pretty quickly if I try and run the PHP version banner now, because I've configured php.ini to include that extension. If it complains about anything, we know that something's gone wrong. But if it just shows the version banner as it's done there, then we should be good. If I run php-m show the loaded extensions, we can now see that we've got fsync appearing in that list. So yeah, we're going to have a little look now at bear with me a moment, we'll have a look at the source code of what we've done and what that's actually added to PHP, and then we're going to expand on it and we're going to make it do something a bit more useful. So yeah, what I've done here is I've got this directory open in Sublime Text, and there's only really two files in here we're interested in, which are phpfsync.h and fsync.c. Header file is very short and pretty self-explanatory. I mean, the only thing we've really got in here at the moment is this version string. The more interesting file, of course, is fsync.c, and we can have, this very, very basic extension generated by the skeleton, pretty easy to understand. It's added two functions to PHP. One of them is called fsync test1, the other is called fsync test2. And again, I mean, without sort of really explaining anything about how PHP extensions work, you should be able to deduce from looking at this. This first one, test1, takes no parameters, and it just prints the extension fsync is loaded and working. PHP_printf is in the C code directly equivalent to calling printf in a PHP script. Of course, that's, you're doing printf in PHP userland, hence the PHP_ prefix. It's not the same as calling the C function printf. Fsync test2, well, that takes an optional parameter of type string. If we supply that parameter, it will say hello, whatever we've typed in. If we don't supply a parameter, it'll just say hello world. Now we'll have a look at that a bit more in a moment, but let's just quickly, we've activated it in this installation of PHP that I have. Let's just quickly try actually calling these functions. So here we're expecting to see the extension fsync is loaded and working, and indeed that's what we get. Test2 should give us hello world, and test2 with a parameter gives us hello foobar there. Now PHP obviously is a weakly typed language, unless you sort of these days tell it not to be. So I can pass in a non-string value here, and that's just going to be, it's just going to be implicitly cast. I would expect the output of this would be hello one, and there we go. Yes, it is. So the extension as it is now is loaded and working. So now we're going to get into the more interesting part, which is why did I call this fsync? What's the extension we're actually building? Well, the answer is that, I mean, I wanted to make a sort of, for the video, I wanted to make a sort of fairly trivial extension that's easy to implement, but I also wanted it to be something that has like a, a useful real world case. So what we're doing here is we're going to implement a function which actually it takes a PHP file handle as a parameter, like the kind of resource you get back from a call to fopen, and it's going to ensure that we actually flush that to disk. Now you might be thinking that's something PHP can do already, but it isn't. If I bring up the PHP manual here, see there is a built-in function called fflush, and it says the function forces a write of all buffered output to the resource handle pointed by the file handle. Flushes the output to a file. So I mean, if you read this, you could certainly be forgiven for thinking that if you have called this on a file handle resource, and it returns true to indicate success, that this means your data has actually been persisted to disk. Unfortunately, this is not so, because this is a fairly thin wrapper at the core around the ANSI CF flush, and what this is doing is this is certainly flushing your PHP applications buffers to the operating system, but it's not guaranteeing that the operating system itself is going to actually write to disk. Operating systems have their own internal kernel buffers, and because they're fond of being efficient, they will accumulate some of your changes and push them out to a physical disk write when they fancy. Now, there are some situations. I mean, normally that's fine. Who cares most of the time if you're running a web application whether a file is written now or in 3, 4, 5 milliseconds. Normally we don't care, but there are situations where we might care about that sort of thing. And one of them is if we're doing anything that's transactional, or where we require durability. If you ever played around with database systems, you're familiar with databases, you have probably come across the ACID acronym, and D is the D in that acronym is durability. And what we mean by that is ensuring that when our application thinks that it's written something to disk, it has actually been physically persisted to the underlying storage medium. That's what we can't do with PHP out of the box. That's what fflush perhaps misleadingly makes you think you can do, but you can't, and that's what we're going to implement. We're going to implement an fsync function, similar to what you get in other programming languages. And that's going to tell the operating system to also force a write of its own kernel buffers to disk, and so that if that function returns true to our PHP script, we can be at least as reliably sure as any application can be that we have that durability, that our data has actually physically been persisted. And there are a variety of situations in which this might be useful. Say you were doing, besides anything transactional, say you're doing, mission critical audit logs, something like that. You really want to make sure that as soon as you've tried to write something and you've got that success status back in your application, you can be sure that even if there's an operating system crash or a power cut at that point, that data is there and it's not going to be lost. And the reason I've sort of chosen this for the purposes of the video tutorial is because I wanted to highlight something that most programming languages can do out of the box that PHP can't. But two, just to illustrate that actually, because you can write extensions for PHP in C, and it's very easy to cross-compile them to different platforms, different architectures, different operating systems, it's not really a weakness in PHP. If PHP is missing some bit of general purpose functionality that you need, well, you can write a C extension to do it. And obviously, what you can write in C is it's unlimited. Pretty much anything a computer can do can be written in C. And this means that PHP is essentially unlimited capability when we start introducing custom extensions. So rather than doing a sort of lot of typing and probably live debugging when stuff inevitably goes wrong along the way, it's a sort of here's one I've made earlier case, and what I'm going to do is these files that we've got from the extension we just built from the skeleton, I'm just going to copy and paste in the modified versions, and then I'm going to walk you through the new function that we've built. And these are very similar to the skeletons. We've just added a bit more to it. So what I'm going to do is in my version string, I'm just going to increment that to 0.2.0, and I've put author name in there just because it's something that we can display and recognize in the module information banner that you will see in PHP info in a browser, just so that we can see that our extension is loaded and working. So in this modified fsync.c file, I've left in the test1 and test2 functions that we've already looked at, but I've also added a new function to PHP, a new PHP function fsync, and I'm going to walk you through that now. So we're declaring some variables at the top here. What have we got? We've got some kind of resource now. This is a pointer to a struct called a zval, which is typically in a PHP extension function. This is what values coming from PHP userland parameters to your function look like, and it's a very generic type. Got an integer, we'll see what that's used for in a minute. We've got a PHP stream structure, because what we're going to do is we're going to take a file handle, a file resource into this function, and we're going to convert that to a PHP stream. And just below that, we've also got a ANSI file pointer, which is what we are again going to convert that stream to. And flushed is going to be a sort of essentially a Boolean flag to let us know whether our operation has succeeded or not. So if you look through the source code of bundled PHP extensions on PHP source GitHub, or you look through other open source PHP extensions, you will find there are actually, probably because of how PHP has been developed and accumulated over time, a few different ways of doing these things in extensions. There are multiple ways you can pass parameters and convert between PHP's internal types and all sorts of things like that. But how I've done it here is one way of doing it, and you're going to see a lot of these things that are in all caps if you start playing around with PHP extensions or PHP source. These are not actually functions in C. These are preprocessor macros. So the C preprocessor is replacing these. These are expanded out into more complicated C code, and PHP source provides quite a few of these things for you just to make development a bit easier. Then pass parameters start, so we're going to pass the parameters into this function. 1 means that essentially it takes a minimum of 1 and a maximum of 1 parameter. In other words, it's got 1 parameter and it's not optional, and I expect that to be of type resource. And we're going to look at that resource type more in a moment, because in PHP, resources are a sort of very indistinct, wishy-washy type. It represents pretty much anything that's not an object or primitive. Resources can be socket connections, they can be database connections, they can be file handles, they can be various other things. And one thing we're going to do here is we're going to make sure that our fsync function only operates on file handles. So next thing we do is a function that is part of the PHP core, PHP stream from zval. So I'm saying I want to take that zval, that parameter that's come in, and I want to be able to convert it to a stream. This function will actually return a warning or error to PHP userland if the resource you've passed in can't be converted to a stream. So that's good. That's going to do a bit of work for us if we try and pass in, say, a MySQL database connection or something like that, it's not a file, we can't call fsync on it. That's actually going to catch that, which is quite convenient. The next thing I'm going to try and do here is I'm going to try and call PHP stream flush on that stream. So this is equivalent to calling the PHP built-in fflush function. This is actually pretty much a copy and paste of what the PHP source code does for fflush, actually. And the reason we're going to do that is because obviously before we force the operating system to write its own kernel buffers to disk, we want to make sure that we've also flushed our application buffers out to the operating system, so that we have this guarantee of durability and persistence of our data. PHP stream flush will return some non-zero value if it failed, so we're going to return false. Again, this sort of preprocessor macro or definition, it probably does just evaluate and expand to return false like that in normal C. But my advice would be, where PHP provides preprocessor constructs for doing things, you should stick to using them, just because there's less chance of something going wrong down the line. So the next line I'm going to call here is PHP stream cancast. Now, this is a particularly important one because if I pass this in PHP userland, if I pass this new function that we're creating, I pass it a resource that is a stream, but it does not represent a file. Lord knows what's going to happen if we try and get a file descriptor for that and call the underlying system fsync. I'd imagine best case scenario, you're probably going to cause a seg fault and crash PHP. So what we're going to do is going to make sure that our extension, our function can actually handle that, and it's going to check that we can cast this stream to a regular C file pointer. And if we can't do that, we're going to throw an exception back to PHP userland. Zen throw exception is the way we do that. Now, the first parameter there, null, what I'm saying there is I'm actually just passing a basic vanilla root exception type. Obviously, you can, if you look it up, if you look up the PHP internals or explore source code, you can use this parameter to throw, say, a runtime exception, a logic exception, or even, a custom exception that your extension has defined. And indeed, if you really get into writing PHP extensions, you find that you can build a module that exports namespaced classes, object definitions, custom namespaced extensions, pretty much anything you could also do in PHP. And then having thrown an exception, we're just going to return false from this function. Obviously, if you're catching an exception in PHP, you're not, the user in PHP there is not going to necessarily get a return value because they're going to be catching an exception instead, but we do need to return out of this function in the C source. So if that hasn't gone wrong, the next thing is that we're actually going to cast that stream to a regular C file pointer, and you can see I've given it the reference to my regular C file pointer there. And again, just if anything goes wrong actually casting that, we're just going to return false. We could do something more fancy to find out what went wrong and perhaps throw an exception, but I think that's, keep it simple for the video. So we're just going to check this, by the way, this preprocessor directive, if Win32, I don't think that's PHP specific. I think you generally do have that underscore Win32 defined in C on Windows in general, and it's just a sort of there might be a better way of checking, but this should do the job. The reason we're doing this is because we want this to be able to cross-compile on Linux and Windows, and actually how you perform an fsync to flush those operating system buffers is different on the two systems. It's pretty similar, but on Windows you can see we use this underscore commit function, which is a wrapper around some other Windows API calls. Whereas on Unix type systems we have the methods fsync and fdatasync. The only difference between fsync and fdatasync is that fdatasync just forces a write of the data, whereas it doesn't necessarily force a write of metadata, such as file last modified time, things of that nature. But I'm only really concerned about the data here. Quite conveniently, other than that, both of them just take the integer file descriptor retrieved from the C file pointer, hence the call to file number there. So those two calls are almost identical. It's just on Windows you have to call a function called underscore commit rather than fsync. And again, conveniently, both those functions actually behave the same way in terms of determining whether they succeeded or not. They will return 0 if they did succeed, and we can be reliably sure that our data has been written to disk. They will return a non-zero value if it hasn't succeeded. So again, nothing fancy here. If it hasn't succeeded, if that call returns a non-zero value, we're just going to return false from our function back to PHP userland. And finally, if everything was fine, we're going to return true. A couple of other things to look at here while we're looking at the source code. PHP init function is the request initialization function. We're not going to do anything with this now. It's actually the function in your extension which is called on every request, as opposed to when the module is first loaded on startup. Minfo is the module info function, and this is where we're gonna display those little purple rows in PHP info that just say version and author name for our extension. And the arginfo macros are used for the PHP interpreter itself. So these are what help PHP avoid calling your function in the first place when the user tries to do it in a bad way. So you can see here with this example, Zenarg type info, I'm expecting a resource, I'm expecting I'm expecting exactly one parameter, I think here, for some reason, I'm defining it as returning a reference rather than by value, which is probably wrong here actually, but well, I mean, it's not going to make a difference to anything in our case. But yeah, I mean, there's some, if you have a look at what that macro expands to, you'll get an understanding of that. But yeah, the purpose of these lines is basically that if I try and pass in, say, a string or a boolean or an integer or whatever else into my fsync function, these lines are what allow the PHP interpreter to pick that up and not even call my function in the first place and just go, no, sorry, this function expects parameter 1 to be a resource and you've supplied something else. This is where we define the functions that we're actually adding to PHP. Not really much to say about that. They're passed down to the module entry structure. And again, this is all generated for you by the skeleton, so you don't really need to know much more about this at the moment. This skeleton doesn't generate a module init function for you, but I might do a follow-up video where I explore some of those a bit more if people watch this one and find it useful. So yeah, I'm going to save that file, and I'm just gonna build it again. And that's great, by the way. That's at least ostensibly succeeded. And again, I'm just copying that updated dynamic link library over to my XAMPP PHP binary installation. And you can see again from the version banner successfully displaying that hasn't gone wrong at the moment. So we're just going to do the old. Great, the extension fsync is loaded and working. So let's see this in action now. If I open a file handle, now great. I mean, obviously we're just, at the moment we're just using the built-in PHP functions. I just wrote the same thing a few times there. So what I was saying was fsync was, you would think, intuitively, you would think that if I call this fflush and it returns true, that means my data has actually definitely been written to disk. No, sadly, it doesn't mean that. That's what we need to have this call to fsync for. So here I'm writing audit logs, or I'm doing something else, transactional, something mission critical. The fact that my fsync function there on the file handle has just returned true is what tells me that my data has actually definitely been written to disk. And again, from having just gone through the source code, we only get that true back if our call on a Windows system to commit, on a Unix system to fdatasync, we only get that true back if that has definitely succeeded. So at this point, we've got this bool true back from calling fsync. Our PHP script, our application, it is as reliably sure as any application can be that our data has actually been persisted. So we've done something useful there. Just to show you, if I try and sort of pass fsync a string, you can see it's generated a type error. Argument 1 must be type resource string given. So that's great. I mean, obviously that's going to be just as true if I pass it like an integer or whatever else as well. But let's say, for example, something else that, remember I said resources are pretty wishy-washy type in PHP. So if I create, for example, a curl handle, you can see, in PHP, that is, again, it's this sort of generic resource type. Well, what happens if I call fsync with that? Because it's a curl handle, it's not a file pointer, it doesn't make any sense to try and call fsync on this. What it should do, if we've programmed our extension correctly, is it should tell us that this is a resource type which cannot be converted to a stream, and that's going to happen because of that line there where we put PHP stream from zval. And great, supplied resource is not a valid stream resource. Okay, so we can see that even just passing in a resource, if we pass as a curl handle, we pass it a database connection, we're going to get a false result from the function, and we're going to get a warning back in PHP as well, which is great. But what about something that isn't a file but can be a stream resource? because we did put in some code to deal with that case as well. So what I'm going to do here is I'm going to use the special PHP protocol wrapper to open a sort of pseudo file handle. I'm going to open a stream to RAM. Obviously, you do this sometimes in PHP when you just want to store some data in memory, sort of simulating file system access. Well, I mean, yeah, let's just quickly do, just to show you that we in many cases we can treat this memory handle as a file. I mean, that's totally fine. But what's going to happen if we try and call fsync on something that is a resource, can be converted to a stream, but is not actually something that can be converted to a C file pointer because it doesn't refer to a file system object. What should happen is that this should throw that exception we programmed in. If you remember, we did this thing where we checked if we can cast it to a standard C file object, and we should get an exception back, a generic PHP exception that says fsync parameter is not a file resource. And indeed, there it is, uncaught exception, fsync parameter is not a file resource. So there we go, that's great, that's all working the way we expect. So you've seen the process for doing this on Windows is pretty simple. If you followed these instructions, it's pretty easy to just to see which bits you need to switch out for different Visual Studio versions, different PHP versions, thread safe, non-thread safe, 32-bit, 64-bit. I think you should be able to work out all that pretty easily, having followed through this process once. What we're also going to do is just see if we can quickly do the same thing. I'm on my machine here. I'm running a Linux virtual machine, and I've got to open an SSH connection to that in my PuTTY window here. So I'm running PHP 7.224 Ubuntu on here, and this, you can see, this is the non-thread safe version, and of course, being Linux, it is definitely not built with Microsoft Visual Studio. So this was a totally clean VM that I just set up earlier, and all I've done is I've run these commands that you can see here on it. I've run apt-get update, and then I've just installed a few packages. You might want to install some other stuff as well, but I mean, minimally, this is all you need to be able to build PHP from source or build a PHP extension on a Linux environment. Obviously, the steps might, the package names and the tool might be slightly different if you're using CentOS or whatever. I'm using an Ubuntu type distribution here. And obviously, I've cloned the PHP source in here as well. And I'm currently on a 7.4 branch. I mean, we should be able to build fine off the PHP 7.4 branch, even though we're building for PHP 7.2. It's just the extension skeleton script is a bit different in this branch and is a bit better and sort of more sophisticated than it produces something closer to what we just did on Windows, which is why I've done that here. Shouldn't really be a problem. So you can see I've just pre-set up here. I've just created an fsync directory. I've run that skeleton generator. And what I'm going to do here is I'm actually going to delete the fsync.c and PHP fsync.h files that were auto-generated, and I'm going to copy from the Windows version we just did. And I'm just gonna paste in exactly the same code that we just built. And having run having already run our sort of configure, build, conf, and configure scripts, we should now just need to run make. And yeah, that's great. On a Linux system, there's then just one more step to actually get it into our PHP instance, which is sudo make install. And that's just copied our shared object. The equivalent of a DLL on a Unix system is a .so, a shared object file. And obviously we just want to enable that extension as well. So we're just going to enable that extension there, and also going to have to do that with elevated privileges. And again, there's no error when I load that version banner. And again, we can see the fsync is on our module list. So again, interactive PHP shell. And we're just going to repeat a similar simple test with the fsync function as we did on Windows. You can see already the process is actually a lot quicker and painless on Linux than it is on Windows. I mean, it's not exactly painful on Windows if you know what you're doing, but it's it's even more painless on a Linux system, because you're really just chucking in a couple of apt-get install commands and then typing in configure and make. So yeah, we're just simply going to do great, that succeeded. That's called fdatasync on our Linux system, and again we have that assurance our data has actually been persisted to the underlying storage now. And I'm just going to close that, and yep, again I'm just going to quickly sort of I'm going to quickly just quickly trigger that exception as well, just to again show that our up-to-date code is working. In fact, there you go, we didn't get an exception there, so it just returned false, which is a slight difference of behavior between Windows and Linux. I'm not really sure why that is off the top of my head, to be honest. It may be that it may just be because in Unix everything is a file. So I mean, opening, the way PHP core underneath implements opening the memory wrapper in Linux systems, probably from the operating system's point of view is something that can be converted to a file descriptor, but nonetheless we can't sync it, so the call fails and we get back false. That is just, that is how Unix systems are. Absolutely everything is a file, even things that are, not files. But there you go. It does catch it if we supply a resource which is not a valid stream resource. So that's great. Everything there is working fine. I don't think there's really, I don't think I've really got anything else to add in this tutorial, other than to say exploring the PHP source code, the source code of the bundled built-in extensions and various other open source extensions is probably going to teach you far more than you can find sort of documented and explained. There are a couple of books on PHP internals and writing extensions. There are a few written resources like that, but the information is not easy to come by in sort of a single coherent form. Anyway, I hope this has been informative and useful to anyone, and yeah, so I'm not sure I'll ever do another video, but I don't know, maybe if this one gets good feedback, I might sort of add to this extension and explore some more things we can do. I'm just going to quickly restart as a final thing. I'm just going to restart XAMPP to reload extensions on my machine, and if I show you this PHP info page on my module listing, if I just refresh this, we can just see that that's our module info that we programmed in. So then it comes out in PHP info. yeah, so that's it from me really. Thanks for watching. Yeah, hope it was useful, and cheers. Goodbye.